So we're closing in on the end. Before we go forward, I thought I just might talk about the T and Z statistics and how do you know when to use what, because sometimes that's a problem. So using T and Z is the title of this bar here. It says use Z if n is large and sigma is known. So if n is large, x bar will have a normal distribution, so when we compute Z using it, everything will be fine. Or if n is small and the data has a normal distribution and sigma is known. So if you see sigma, you have to use Z, and you can only use Z with small n if the data is normally distributed. You can use Z no matter what if the n is large. But you have to know sigma, the population standard deviation, so look for that. If in your problem it says something about the population standard deviation, then you're going to be doing Z, Z intervals, Z test, Z whatever. Number 2, use T if n is large and S is known. S is the sample standard deviation. So once again, if n is large, x bar will have a normal distribution by the central limit theorem, so we don't worry about the distribution of the population when n is large with T or Z. There's S though. If you see S, you really don't have sigma, so you can use T to do things. If n is big enough, T is going to look just about like Z anyway, but you go to the tables and use T. If n is not large, we still need S, and we have some rules of thumb. For small n less than 15, data should be single-peaked, approximately symmetric, and not have outliers, and we can go ahead and use T. If n is bigger than or equal to 15, we want to make sure the data has no outliers or strong skewness. And then once we get to 40, we go, no worries, go ahead and use T. It's big enough that everything washes out when you average. So we'll be seeing examples of that in the problems that come up. Here's the first one. 32. Scores usually have a mean of 750. From the data provided, I got x bar was 747.13 and S was 61.4. I hope I did it right. N was 15. So N was 15 is in this moderate sample size. So we want to make sure the data has no outliers or strong skewness. And the histogram shows no outliers or strong skewness. The histogram is there. It says, can T be used? Yes. What does T look like? In hypothesis testing, it looks like this, just like Z, except where S is for T, sigma is for Z. It says test whether or not it looks like the mean has increased. I'm on 32, I hope I did this right. Is there evidence the mean score is now higher than the general population? You're thinking it is? You're going to go out there and collect the information and see if it is. And if you did that, and you looked at the sample mean when you got done, you probably just stop right there. Because I'm looking for evidence the mean exceeds 750. My sample mean is less than 750. I go here. This might make us think the mean is less than 750, but not the mean is greater than 750. Okay. So true. I would have stopped a minute ago, but I'm keep going anyway because maybe I just didn't notice, or maybe I asked someone to carry out the calculations for me, and I didn't have the data. I just told them to go do it and report the results. So they went ahead and did it. They got a t-value of minus 1.81. Like if you put it in a computer system, it'll do things. We know it's a greater than alternative, so the p-value is the probability of being that number or larger in the t distribution, just like it would be in the z distribution because it's a greater than alternative. Ordinarily we get numbers out here which indicate that the alternative is probably true and a small p-value, but if we get this number over here, we get the p-value is this giant number, the area under the curve, we're past 0. So we'll say the p-value exceeds 0.5, it's bigger than 1/2. Large p-values do not cause you to reject the null hypothesis. You need small p-values less than 0.05. Here I have one bigger than 0.5. Big values cause you not to reject. Bigger than 0.05 cause you not to reject. Bigger than 0.5 make you throw your hands up in the air and go, what's going on here? I think we asked the wrong question. Conclusion, we do not reject the null hypothesis. In fact, if you were reporting back, whoever asked you to do the analysis, you would just say, well, look at that. The x bar we got is so close to 750, we have no reason to doubt the mean being close to 750 at all. Probably if you expected it to go up, certainly it doesn't look like it did. probably just the same as it was. Might even have gone down, who knows. And there we go. So we're getting close, and I'm running out of time, so I'll take a break for a bit. I'll go post these, and we'll be talking later.